process. So, all right, everybody. So it's lecture 18, and we're in chapter 9, electricity. I also wanted to show you this little link here. I had Vince send me an email and let me know that he was interested in joining us live. I'm the only person in the room, as you can see here on the left, but and we've got kind of a light crowd in lecture today. But just wanted to remind everybody, this is a third option for joining lecture. You know, you can come live for the lecture. You can join us live online through Blackboard, and that link is very easy to find. I'll just show you where that is. So I'll get into the shell, Energy 101. The link is right here, and so if you're caught in a snowstorm, wife's busy delivering a baby in the hospital, what have you, you can still join us here in lecture if you have access to the internet. So that's another option. And then, of course, everybody knows that we've been archiving the lectures, and they're all in YouTube videos right down through the shell. Okay, so just a little reminder on the 3 modes that you can join us in lecture. And now I'm going to launch a little problem. Actually, let me save this old one here. We got pretty fancy in recycling technology today. We did numbers, units, and powers of 10. So that was a lot of fun. I'm going to save that guy. Recycling technology 2010, lecture 14. This was okay. I'll put that baby to bed. And Tim had just sent me a problem, and I'm just going to go ahead and start reading it out loud now. And so LED light bulb problem. There it is. And at the beginning of the course, we did a problem about light bulbs and how much energy they consumed per year. If we have 5 incandescent 60-watt light bulbs that are on 8 hours a day, electricity costs 10 cents a kilowatt, what's the annual cost to run the lights? The next problem involves replacing the incandescents with LEDs. Incandescents are 75 cents each, while an LED is $11 each. The lifespan of the LED is 25,000. The lifespan of the incandescent is 1250. The LED uses 10 watts of electricity, which is 1/6 of that 60-watt incandescent. It says we will use the same numbers from the original question, how much money would be saved over the lifetime of the LED light bulbs if we use them to replace 60-watt incandescents. So Tim's over on the board working this, and let me show here's the problem that I just read to you. And we'll parse it out in terms of the information that we need to arrive at a numerical answer. So in the interest of time, I might, what was the amount on the 60 watters running for 8 hours a day annually?
I don't know annually. I figured out by day because it's going to be the easiest way to do it all the way around.
Okay.
It costs 24 cents per day to run our incandescent bulbs.
Okay.
That's 2.4 kilowatt hours at 10 cents a kilowatt hour.
Okay, so split the screen here so I can see both of them. So, let's run this. So
I just did 5 bulbs times 60 watts times 8 hours.
5 bulbs, 60 watts, 8 hours, and then
Excuse me, 2,400 watts per day.
2,400 watt hours.
Yeah, watt hours. Yep.
Watt hours per day. Okay.
And then just did the conversion to kilowatts so I can get my price.
Okay, so then we're looking at 2.4 kilowatt hours per day. And then at, so then times, so 2.4, I'll just kilowatt hours per day. 0.1 dollars per kilowatt hour equals 24 cents, right?
4 cents a day.
0.24, okay, per day, all right.
We can do the same thing with the LED. They operate at 10 watts. So it's 5 times 10 watts times 8 hours per day,
Okay,
which gives us 400 watts.
8 hours per day gives us 400 watt hours. And then, so what are we looking at?
And that's per day, so it's 4 cents per day.
4 cents per day. So I'll just skip the steps, but obviously 1/6 more, because, you know, the power, 10 watts is 1/6 of 60, so 4 cents per day. Per day. Okay?
So the next thing we can figure out is cost.
Mm-hmm.
We know that if the LED lasts 20 times as long, one LED costs $11.
Yep.
And we're gonna need 20 incandescent bulbs to equal the same. So 20 at 75 cents a piece is $15, or one LED is $11.
Okay.
So right off the bat, to replace those 5 bulbs, we're saving $4 each, or a total of $20.
Okay, so what's our incandescent cost again?
75 cents per bulb.
Okay, and then times, okay. And
Times
then
20.
times 20. Because and you're getting the 20 from,
The LED bulb lasts 20 times as long.
right, so let's pop that out. So if we got 25,000 hours, that's the lifespan of the LED divided by 1250 equals, so there you go, 20 times longer. So this 20 means we're gonna use 20 times more incandescent bulbs. That's where that's coming
Right.
from. Okay, and then what?
So that works out to be $15 in cost of incandescents.
Okay, there we go. Right, and then
And
and then the-
LED is just as is.
Right.
It costs $11.
gotcha. $11 times 1 is $11. Okay.
So then we get into that lifespan. If we know it lasts 25,000 hours, we have to divide that by 8 to get the number of days that we're using it.
Okay.
So 25,000 hours divided by 8 comes out to be 3,125 days is the lifespan of it.
25,000 hours divided by 8 hours per day equals, well, that's a good long time.
Yeah,
Okay.
almost 10 years.
3,100 days, okay. 3,120.
So now I can take those numbers. I know the difference between my two prices is 24 cents per day compared to 4 cents per day.
Right?
So my savings every day is 20 cents. So I can multiply that 31.25 times 20 cent savings every day.
Okay, so we'll look at the change in price. So we were at 20, was it 24?
24.
Okay, minus 4. 4 equals 20 cents per day. Right? And now,
Multiply that times our 31.25, which is our days of lifespan.
whoa, okay. Times 0.2 equals $625.
$625 in savings just in electricity.
There we go.
But we also know we bought 5 bulbs for a savings of $4 each. When
Okay.
we compare that to the 20 incandescent bulbs we have to buy to match it.
Okay?
So 20, let's see, $4 difference in price for each bulb times 5
right,
means we saved another $20 just in purchase price of the bulbs.
right.
So our total savings is gonna be $645.
Okay, so we're looking at 15 minus 11 times 5 equals $20
Yep,
right now, plus your 625, so 645 total?
yep.
Okay. Nice. So, couple of other things to consider here, and this is looking forward towards ETEC 214. And there's a little bit of that in this textbook too, but there's this whole notion of the time value of money. So someone might say, well, gosh, I'd love to save $625 in the future, but you know what? Sorry, but I don't have $11 now. And so, this is a problem. This is the same problem in every single capital problem you'll ever see. It's like, unless you've got some money now to spend on the new infrastructure, you might prevent yourself from saving the money later. So then this is going to be true in every
And I
single
found this
system.
argument with my wife. The cool argument here that's fun with the light bulb, you save $62 per year, or about $5 a month on your electric bill by doing this, because it was $67 a year for your 60-watt bulb,
Mhm.
compared to your saving $62 per year. And now when I start doing that math, every 2 months I can buy an LED light bulb with my savings in electricity.
Mm-hmm. Yeah, yeah.
Um,
Yeah. So I think what you're saying there is if you can chop it up into smaller units of time and say, I'm going to save that like tomorrow or next month, and I don't have to wait 20, 30 years, then it's a better argument. Yeah. And that's also going to be true with, in our larger energy policies too. Okay, so, coal's trading at, selling at $15 bucks a ton, but what's all the real estate in Florida or Manhattan worth? In terms of having to lose that to the rising ocean. So yeah,
Or
Good.
put a price tag on the air you breathe in.
right. Or yeah, absolutely. There's somebody just sent me a deal where if you breathe too much CO2, you get dumber. And, so there's my excuse.
That's science is shaking.
You can't think as well if you're, breathing your own exhaust gas. Yeah, I can see that. All right. Well, thanks, Tim. And so yeah, it's good to keep these little problem set guys going and keep moving.